What will space operations look like in the future? With display, computer, and IT solutions changing rapidly, it is hard to imagine what exactly the space operations control room of the future will look like, or how communication technologies will change. In the near term, however, we know what we would like to see in the next 5 to 10 years. For one thing, agencies across the globe recognize that we need more international collaboration on future Earth orbital and exploration missions, whether human or robotic. Collaborating agencies have begun working to forge new agreements to utilize new technologies. Currently, we are working to automate network routing in deep space with delay or disruption-tolerant networking, called DTN. Today, humans configure these networks, scheduling and maintaining static, predetermined routes, slowing response times to failures. Unlike the Internet, when nodes fail, human intervention is needed. A new approach is needed, one that contains intelligent nodes, making near instantaneous routing decisions in a dynamic, real-time environment. Today, we enjoy the benefits of the Internet with rarely a thought about the speed and complex automated routing that enables us to take it all for granted. As humans have pushed back the space frontier with a permanent international presence in low Earth orbit, we've adapted that Internet technology for a few in-space applications, and we're expanding the International Space Station's role as a test bed for more advanced Internet technology. But what will happen as we routinely expand both robotic and human exploration beyond a near-Earth orbit? New challenges and opportunities emerge in an environment where data transmission takes seconds, several minutes, or even longer. The current structure of the Earthbound Internet works well on our richly connected planet, but it doesn't work in the distant and disconnected solar system. The routing of data from Earth, for example, to a robotic lander on Mars, currently relies on a labor-intensive and disruption-prone series of paths that are vulnerable to a variety of single-point failures. Commands must be routed through a series of communication nodes and then on to Mars. Imagine scheduled commands leaving Johnson Space Center in Texas or the Jet Propulsion Lab in California, limited to only when every node is available. Now imagine a human mission endangered because the communication link is lost because of its orbit or availability. Critical life-saving time or priceless data could be lost because of an inability to buffer and reassemble that communication. DTN enhancements will address these issues by providing an alternative to the current all-or-nothing approach. To ensure both faster and more reliable transfer, DTN bundles of data will be stored and forwarded in an internationally standardized, autonomous mode to the next available link in the communications chain. To smoothly transition to the future communications environment, some very obvious steps need to be taken. Moving from lag time or latency of a few seconds near Earth to as much as 40 minutes in Martian orbit will require a blended approach that more reliably integrates terrestrial and space-based networks. The new space internet working environment will integrate traditional spacecraft data types, command, telemetry, voice, video, plus new data types like email browsing and message bus technology in an autonomous and standardized architecture. A solar system-wide, highly efficient communications network will need to integrate DTN and IP technologies. That system will depend upon control centers and space communication communities developing a common set of protocols and architecture. That is where CCSDS, or the Consultative Committee for Space Data Systems, comes in. While the group's title is cumbersome, their objectives are essential if we are to produce international standards that make cooperation possible. The committee is composed of 11 member agencies, with an additional 26 agencies as observers. Virtually any nation or organization interested in space is represented in the numerous working groups. The working groups range from mission ops to space internet working, cross-support, space links, and spacecraft. While a start has been made, there is much work ahead. The goal of collaboration between agencies and nations is challenging, but the rewards are worth the efforts. Investing in a reliable and efficient deep space network that has automated routing and is delay and disruption tolerant will pay dividends for generations to come. Without it, both cost and safety will be adversely affected. In essence, we can't afford not to make these efforts. We owe it to ourselves and following generations to lay the groundwork today for a communications and control system, a solar system internetwork that will deliver the dream of extending human reach wherever we choose to explore.